A radioactive nucleus undergoes a series of decay according to the scheme A alpha decay becoming A1, then goes to beta decay becoming A2, again alpha decay becoming A3, and finally another alpha decay becoming A4. So, if the mass number and atomic number of A are 180 and 72 respectively, then what are these numbers for A4? What are these numbers for A4? So, it undergoes from A, it undergoes alpha decay. So, the mass number is 180, atomic number is 72. Goes to alpha decay, becomes A1. So, then undergoes beta decay, becomes A2, and undergoes another alpha decay, becomes A3, and undergoes another gamma decay, becomes A4. Okay, this is what the given question is. Now, alpha decay means it emits alpha rays. So it emits out, see, A 180 72 becomes A1XZ plus 2HE4. So, this Z must be 180 minus 4. 180 minus 4. And X must be 72 minus 2, because alpha particle has been emitted out during alpha decay. So, A1 is this. Beta, during beta decay, what happens? A1, which is 70 and 176, gives to A2 X dash Z dash, but beta particle is minus 1 and no change in its mass number. No change in its mass number. So, X dash will be minus 1, X dash minus 1 will be 70, implies X dash is 71. Z dash remains the same, 176. So A2 can be written as 71 and this is 176. 71 and 176 during beta decay. Again it undergoes alpha decay. Here I have explained, you reduce the atomic number by 2, mass number by 4. So A3 will be 67 or 69 it is. It is atomic number, no? 69. Mass number you have to reduce it by 4. Atomic number by 2. So from 72 to, it is undergoing series of decay, no? So from 71 to 69 it will become, and from 176 to 172 it becomes. During gamma decay, no change in Z as well as A, that is no change in mass number and atomic number. Only it gives away energy. So A4 will have the same atomic and mass number as A3, which is 69 and 172. That is option A is the correct answer.